Now we're going to take a look at the tangent and cotangent graphs. Now here's a drawing of both of these on the board there. So we see that for tangent and cotangent they look way different than sine-cosine graphs. Now what makes them different is you actually have asymptotes on these, vertical asymptotes. In the tangent we see that they're on the half pies like this, and on the cotangent graph they're on the whole number pies. Now the reason why we have this is that's where you have division by zero. If you think about definition for tangent, we can write that as sine over cosine. So wherever cosine equals 0, that's where you're going to have these vertical asymptotes. So cosine of pi over 2 is 0. This would be 3 pi over 2 over here. That would be a 0, and so forth. For the cotangent graph, you have, that's cosine over sine. So wherever sine equals 0, that's where you're going to have a vertical asymptote. So this is 0 right here, so you have sine of 0 is 0, sine of pi is 0, and so forth. That's why you have these vertical asymptotes here. Now if you think about one cycle of this, one cycle would be from negative pi over 2 to pi over 2. That would be one cycle. And if you subtract those, pi over 2 minus a negative pi over 2, you get pi. Same with this here, from 0 to pi, that would be one cycle. So what I have drawn up here is actually two cycles of each of those. So for both of these, the period is going to be pi. Okay, so here are the general forms for tangent and cotangent. Notice we still have the A, B, and C, which is similar to when we were doing sine and cosine graphs. However, what's different now is the period. The period is pi over B. Okay, and that's because the graphs for it, one cycle is a length of pi. So again, these look completely different than the ones that we looked at before. That's why it's pi over b, not 2 pi over b. Earlier we talked about with when you do sine, cosine, secant, cosecant, we have the quarter point that's used to get our key points. Well, for tangent and cotangent graphs, we have what's referred to as the half point. So the half point would be period divided by 2 instead of a quarter point. We have less key points when you're dealing with tan and cotan graphs. Now look at the phase shift formulas. It's different depending on whether you have a tangent or cotangent. If it's a tangent graph, then it's c over b, but then you have to subtract pi divided by 2b on it. So this is a difference in the ones we looked at before. Whereas cotangent is actually the same as sine, cosine, secant, and cosecant, just c over b only coming from this formula. As before, like we talked about with the sine and cosine graphs, if this part inside is minus, that means your c over b is positive. But if you have a plus inside, then you'll turn out to have a negative c over b instead. You're always going to take the opposite sign of what you see inside here, as we talked about before for sine and cosine graphs. Now notice one thing that you do not see here that we had in our other graphs. We had an amplitude before with our sine, cosine, secant, and cosecant graphs. So if you notice here, we don't have an amplitude. That's because tangent and cotangent don't actually have an amplitude. Now the A value that you see out front there, what that ends up being is a vertical stretch. So it's going to stretch the graph out, either stretch it out, or it might be a compression, depending on whether that is if it's a number greater than 1 out front there. That means the absolute value of that, if it's greater than 1, then it'll be a stretch. But if you have a fraction in front of that, it's going to be a type of compression. So these kind of problems only going to ask you for just the period and phase shift on these, but there's no amplitude that's there. When we get into the graphs, I'll talk about how you use the A value, what happens to that, and how you can get the specific points by using that A value. But again, there's no amplitude with these. It's just period phase shift that we have. It'll ask you the half point we're going to use with graphing. So next, let's take a look at some examples where we're plugging numbers into these formulas.